In this video, we are going to check whether a number is an Armstrong number or not. You already know that a 3-digit number is an Armstrong number only if its sum of cube of digit equal to that number itself. In this code segment, you have 3 sections. The leftmost is the Python code followed by the code segment which containing assembly level instructions corresponding to this Python program. Followed by you have a data segment where the data are temporarily stored. In order to do the arithmetic operation like comparison, addition, subtraction, you have to move this data between the data segment and the CPU registers. To get start executing, you have to click the start button here. Then first line will get executed and it created data storage in the data segments. To proceed further, click the forward button here. So now your third line in the code segment is executed and it is indicated by a light blue color background. And the high level instruction that is in the Python code corresponding to the third line is indicated by a green color arrow here. Now it's prompt you to enter some number. Here I am entering 153 as input, then click the submit button. To proceed further, keep pressing this forward arrow and you can see that the data is moving between the data segment and the registers. So temporary variables are populated accordingly and we are using a loop statement, especially while statement to check whether a number is an Armstrong or not. First, we are checking whether the number is greater than 0. If the number is greater than 0, then we want to extract the last digit by using the modulus operation. Then, that we are finding the cube of that extracted last digit and adding that cube to the previous sum. Then, we have to remove that last digit from our input by a floor division operation. This operation will continue until our input became greater than 0. Once the input becomes lesser than 0 or equal to 0, the loop will get terminated and the following instruction like sum and the input number is same. If both are same, we are printing the output as the given input is Armstrong. Otherwise, we will print it is not an Armstrong number. So, the intermediate results are showing at the bottom part of the screen. Only few CPU registers are available, so you need to manage it efficiently. That's why data are moving between your CPU registers and the data segment. So we extracted the last digit. The last digit is 1. And 1 is greater than 0, so we need to run the while loop once more. So 1 is greater than 0 is true, so we need to extract that number also. Then we need to find the cube of the last digit, that is 1, and we have to add that value into the previous sum of . So this cube operation has to be done in 2 lines in the corresponding assembly language. In assembly language, you can't add the 3 numbers at the same time. So now our input became 0, so 0 is not greater than 0, so the condition is became what? it's false, so that the while loop get terminated, and the next instruction after the while loop, that is the 8th line here, will get executed. So in the low level instruction, the if statement is at the L0 label. In L0 label, we are checking whether our sum and number are same, so both are loaded into the CPU register. Then using EQ statement to check whether they are equal. If it is equal, we are printing Armstrong as an output. Here you can see the output. That's all in this video. Thank you.